All right, so today we are working with 4.8, working with solving equations with fractions. Now we've already seen a little bit of this on the previous test. We've seen a little bit of this on some of the previous homework, but we're going to formalize it and go through a bit of a review with this as well. So I'm hoping a fair amount of this does come across as a bit of a review, or at least something that we've seen or we're familiar with in some way, shape, or form. So first and foremost, this is just expanding on what we did in section 3.5. Solving equations as a generality, except now we're throwing fractions into the mix. So when we are working with adding or subtracting anything, we're going to do everything the exact same way as we were adding or subtracting something to both sides of the equation before. If I'm going to add a number to one side, I'm going to add that exact same number to the opposite side of the equation. The only difference is that now we can have those numbers be fractions. Previously, we worked with whole numbers or integers, positive 5, negative 10, positive 13, negative 100, things like that. So now we can add or subtract 1/2, 1/3, 3/4, 5/8, 9/7, anything like that. And remember that when we are adding or subtracting fractions together, remember that we need to have a common denominator to combine those fractions to be a single one. So our process to find those common denominators, that's back from section 4.4. Review that as necessary. You're absolutely going to be needing that. Now, multiplication and division, again, it's the exact same thing as we did in the past with multiplying fractions together. It's pretty straightforward on that front. The main one that we want to go through, and this is where we have a trick that's showing up. To quickly undo a fraction that's attached to a variable by multiplication, so we can take a look at our example that we have, let's say right here, and we'll go through this one in more detail. One of the ways we can do that is instead of dividing by a fraction, which has some extra steps attached to it, you can instead multiply both sides by the reciprocal of that fraction. And the reciprocal is just taking the fraction and flipping it on its head. So what's in the numerator goes to the denominator. What was in the denominator goes to the numerator. And the main reason we have this, or we want to use this, is it all stems from this thing we have, the multiplicative inverse property. Kind of a fancy way of having this really nice tendency that shows up with fractions. So what this actually is, we're going to let a over b be any fraction. Let a be a number, b be a number, your two favorite numbers in the world. The number b over a is called the multiplicative inverse, or the reciprocal, of a over b. Reciprocal is the more commonly used terminology that we see with this, but again, it could be written out as the multiplicative inverse. It means the same thing. And what's really nice about this is the product of reciprocals is always going to be 1. And this is really nice when we get to actually working with problems where we need to get rid of something and get a single 1 in front of a variable. We'll go through this example and I'll show you the two ways that this can be demonstrated, but this is our overall property that we have. So if I have a over b times its reciprocal b over a, then my result is always going to be 1. If we multiply straight across, a times b is equal to ab on top. B times a is also equal to ab, just on the bottom. ab divided by ab, anything divided by itself is just going to be 1, so we get 1 for our answer here. Kind of condensing steps down, but you could write this out, show every single step for yourself, and you'll get that answer. Now, we're going to go through a couple examples with this, because I do want to show how this can work if we keep things all written out as fractions, primarily using this multiplicative inverse property, or the reciprocal, to get rid of our denominator here. So I'm going to jump us over to the whiteboard, and we'll go through this example here, and we'll go through this example here as well. So these are the two that we're going to reference over on our whiteboard. Okay, bring it up on my other screen here so I'm writing the right stuff in for you guys. Okay. So our first example that we were working with So we were given 2/3 x plus 1/3. Ooh, 1/3, not whatever that was. Was 5/3. Okay. So our previous properties for addition, subtraction, multiplication pretty much hold true as we have here. Our goal with this, I want to solve this thing for x. I want x all by itself on one side of this equation. So I want to get the variable terms to one side of the equation. That's already done. All of the x's are over on the left side, so that's good. And now I want to get rid of all of the constant terms that are also on that side to get the variable terms by themselves. So this 1/3 is attached through addition. I want to undo that, so I'm going to subtract 1/3 from the left side. And if I'm doing that from the left side, I need to do that to the right side as well. And on the right-hand side, let's cancel there, I have 5/3 minus 1/3. The denominators are the same, so I can subtract the numerators. 5 minus 1 is going to give me 4. I get 4/3. Now I want to show you guys that there are two ways that you can do this. It's your call, whichever one you would like to use. So I'm just going to list out here that we have two options for this. So our first option that we have is using what we've used up to this point in time. Well, I have something in front of x. It's attached through multiplication, so I'm going to divide both sides by that thing that's multiplying out front. And you can absolutely do that. Here's what's going to happen, though, and this is where I would advise maybe not using this option as often, purely because of what this entails, but divide both sides by 2/3. And if you're looking at this going, wait a minute, that's a fraction being divided by a fraction, you're 100% correct. And the nice part is on the left side, again, anything divided by itself, it cancels out. But on the right-hand side, now I have a fraction divided by a fraction, and we have to do some extra steps to work with that. So I'm going to rewrite the right-hand side explicitly as 4/3 divided by 2/3. Same thing that's written above. Again, a fraction implies division. And now I'm going to rewrite this thing as multiplication. We flip the second fraction and multiply. I can cross cancel the 3's. I can simplify the 4 and the 2. And I'm going to get x equals 2 for my final answer. Okay. Again, there's nothing wrong with this method. It gets us the correct answer. The main reason why I'd be a little cautious with using it is, one, we divide by a fraction in our step that we have right here. And then it also requires that we can properly rewrite that division 2 times. There's a bit more involved with that, a bit more that we have to keep track of when I'm using this method. Again, nothing wrong with it, but I'd just be very careful when you're going through that and be very methodical with what you're doing. Alternatively, I think this is the easier method, quote unquote, but this is using the multiplicative inverse property. So instead of dividing by 2/3, we say, I want to get rid of that fraction. I want that to be a 1 out front. So I'm going to multiply both sides of this equation by the inverse of the fraction attached to the variable. So I'm going to multiply both sides by 3/2. On the left-hand side, cross cancel, 3 on top, 3 down below, it cancels out. 2 on top, 2 down below, cancels out. I'm left just with x. On the right-hand side, again, cross canceling, the 3's cancel. 4 becomes a 2, 2 becomes a 1. I get 2, my final answer. And again, the really nice part, it gets us the exact same thing as our other method, but we essentially start at the step that we have right down here. So we bypass 2 full steps of work by using the multiplicative inverse property, which is really nice. Okay. So again, as you're going through these things on the homework or on the test, it's your calls to which one you would like to use. Both will get you the same answer, as we have demonstrated here, but it's your choice on which one you would like to work with. Okay. I'm going to go with another example that we had from that page. Zoom us in here a little bit. All right, so our second example, again, that same page of work that we had. Yep, there we go. 8/3 of y minus 1 is equal to 3. Now again, we can have fractions mixed in with integers and whole numbers. That's fine. It's pretty regular to have that happening. We're going to be doing our same process all the same. So I have my variable terms all to one side. I want to get rid of that minus 1. I want to get the variable terms all by themselves. So I'm adding 1 to both sides of the equation. The 1's cancel on the left. I get 8/3 y is equal to 4. And again, I don't want to divide by a fraction. I'm going to multiply both sides by the inverse of that fraction to have the fractions cancel out. I think it's a bit better, 3 here. There we go. So I multiply the left side by 3/8. I multiply the right side by 3/8. Better 3 there. There we go. And remember, whenever we have a whole number, is always implied to be over 1. We don't write it out like that explicitly because of all the invisible ones that surround most numbers or terms or anything like that. But it is always implied to be divided by 1. Now on the left-hand side, fractions cancel entirely. I'm just left with y. On the right-hand side, the 4 and the 8, 4 becomes a 1, 8 becomes a 2. 1 and the 3, nothing cancels there. Multiply the fractions straight across. So numerators multiply together. 1 times 3 is going to give me 3. Multiply the denominators straight across. 1 times 2 is going to give me 2. And I get y is equal to 2/3 as my final answer. Okay. This is going through and using our method where we're going to keep the fractions in. Multiplying or adding, subtracting, multiplying, and dividing things together. Just like that. Okay. Now I'm going to jump us back to our notes because there is an alternative method that we can go through to solve these problems, which is one we've already covered, but I want to go through and show it again with our notes that we have for it this time. So the alternative method that we have, and I recommend using this one if we have some fairly gross numbers or a lot of fractions showing up in this thing. We can eliminate fractions altogether, which I'm going to go out on a limb here and say a lot of people don't like working with fractions. I'm just going to guess at that. So what's nice about this method that we have, it gets rid of them altogether for us. And you're more than welcome to use this as well. So the way we are doing this, the way we're going to clear all the fractions from both sides, it means we need to multiply both sides, meaning every single term, all the terms that we have showing up, by the lowest common denominator of all fractions that appear in the equation. So this can only happen after we have fully simplified both sides of the equation and before we start adding or subtracting things to both sides of our equation. I want to advise caution on this. Do not rush the distributive property as you are eliminating these things, especially when you're trying to multiply and reduce at the exact same time. Errors occur very commonly here, and a lot of people miss a lot of points when they do this. Okay, so this can make your life very, very, very easy if you're going through problems with fractions. It's a great tool. However, to save you some time at the very end, take a little bit of extra time and slow down and don't rush yourself as you are going through and actually eliminating these things. A lot of people rush it, and a lot of people lose a lot of points from that. Take your time. Another trade-off that goes along with this, while it does eliminate fractions, it does sometimes mean we get larger numbers showing up for the rest of the problem. In some instances, we could have things closer to triple digits in size, but again, I'm going to go out on a limb here and say I feel like people would probably be more interested in working with larger numbers than fractions. I'm guessing. And by guessing, I mean I'm pretty sure that's going to be the case. So these are the two examples that we are going to reference over on the whiteboard. We're going to go over and take a look at these, our process, and we've got to have them detailed out here already, but actually see the process written out for ourselves. So we'll jump over there. Let's take a look at those. Okay, we'll zoom us in here a little bit. All right, so our first example, we're working with 1/2 x minus 1/2 is equal to 3/2x plus 3/4. Okay, so first and foremost, we're looking at, are both sides fully simplified? And again, simplify following PEMDAS. Can I add or subtract, multiply or divide? Do I have parentheses? Do I have exponents showing up on either side of the equation? And again, when we are looking at that, we're saying I'm just looking at the left-hand side. Can I apply PEMDAS to that? No, I can't. I cannot add or subtract these things together. One is a variable term, one is a constant term. I'm looking at the other side, asking the same question. Can I apply PEMDAS to this? And no, I can't. One is a variable term, one is a constant term. There's no other operations going on there. So both sides are fully simplified. Great. Now I can work with the process that we just went through where we're going to eliminate fractions. So if we are going to eliminate fractions, which that's the plan, we need to determine what is the lowest common denominator between all of the fractions that show up in this problem. And the lowest common denominator in this case is going to be 4. Now there's a couple ways you can write this out for yourself. I'm going to go through and show multiple steps with this because I think it's worth seeing. But again, our process says I'm going to take and multiply both sides of the equation, meaning every single term, by that lowest common denominator. So again, all I'm doing is just detailing this out. So I'm multiplying the entire left-hand side by 4. I'm multiplying the entire right-hand side by 4. Which means this 4 is going to distribute through to both things, both sides. So again, I'm going through and showing the kind of long drawn out every single step with this method. Again, every single thing needs to multiply by this. The things that a lot of people do with these problems is they will write the step that I have written out above. They will just write out this, and they'll only cancel this 4 and call it done. Or they'll only cancel this 4 and this 2 and then call it done. That's 100% incorrect. We can't do that. So the starred line that we have here is optional. But our third line that we have here, kind of the double stars, you absolutely must do that step if you're going to eliminate fractions. If you do not do that step, you're going to lose a lot of points. I'm very, very strict on what partial credit I give in this section. We don't show our work on that front. So on the left-hand side, we're going to go left to right. I have 4 times 1/2 x. 4 times 1/2. Again, remember, all whole numbers are implied to be over 1. The 4 and the 2, those cancel. I get 2x minus 1/2 times 4. It's going to give me 2. On the right-hand side, remember 4 over 1. 4 on top, 2 down below. The 4 becomes a 2. 2 becomes a 1. Cross-canceling there. Then we have 2 times 3 over 1 times 1. So that's going to give me 6x plus, and the 4 and the 4 cancel. And we're just going to get 3. And now our fractions are eliminated. We only have whole numbers that we're working with, which is great, or integers, I should say. And now we can add, subtract, multiply, and divide just like this was a chapter 3 problem. So I'm going to get rid of the variables on one side. X, that's better there. Get rid of the constants on this side. I'm getting -5 is equal to 4x. Divide both sides by 4. Should stay consistent with my colors here. The 4's cancel. And we get x is equal to -5 over 4 for our final answer. Okay. So again, our first steps of finding that lowest common denominator, multiplying both sides, meaning every single term by that lowest common denominator, should yield only integers, which is really nice. So we'll take a look at our other example from that same page. So our other example, we had 9/4 x plus 4/3 equals -1 over 6. And again, our goal with this one, we're going to work this by trying to eliminate our fractions. So we need to find the lowest common denominator between all of our fractions that show up in this problem. And again, our lowest common denominator is the same as saying, what is the lowest common multiple between all 3 of the denominators that we have here? And in this case, the smallest number that 4, 3, and 6 all multiply into is going to be 12. So that means every single term in this problem is going to multiply by 12. And after we do that, we're going to cancel out all the fractions and we'll only have integers left over. So I'm going to write this out a little bit differently from last time, skipping one step, but again, writing the more important one in. So it means this term by 12, this term by 12, that term by 12. And again, to cancel things out, remember that all whole numbers are implied to be over 1. Going left to right, we have 12 on top, 4 down below. Which is going to, there we go. So this is going to give us 27x. Going 1 over, I have a 12 on top, a 3 down below. 4 times 4 is going to give me 16. And on the right-hand side, I've got 12 on top, 6 down below. Multiply straight across, and that's going to give me a negative 2. And now from here, again, our fractions are eliminated. This is a chapter 3 problem. So I want to get the variable term all by itself. So I'm subtracting 16x from both sides. Cancels over there. I'm getting negative 18 on the right-hand side. I do not want 27x. I just want x, I should say. So I divide both sides by 27. X is going to be equal negative 18 over 27. Then we always ask ourselves, can we reduce this fraction down any further? 9 evenly divides into both of these, which means this can reduce down to being 2/3. We have our final answer there. Okay. So again, as we're seeing these things, there are lots of options to go through and solve these problems. We have the method of eliminating the fractions entirely from the problem. And again, there's 2 ways you can write that out for yourself. This second line of work in our first example is optional. If you would like to write it out this way, you're welcome to do so. But this third line of work that we have on our first problem, or our second line of work that we have on the second problem, is one that you absolutely must do. You cannot afford to skip this step or try and do all of it mentally. I highly recommend you write that out for yourself, because you're going to have different things canceling in different parts of the problem, and that's fine. That's to be expected. But again, a lot of people try and do this second line of work over here and then mess up. Oh, I canceled this part out there, and then I cancel some different thing out someplace else, and work gets all over the place, and we lose track of it. Numbers get thrown around, errors happen, and the answer is then wrong. So be very, very deliberate with what you are doing from your first step as you're eliminating these fractions. And then once the fractions are gone, then yeah, this should be stuff that we are very, very, very familiar with, because we're doing this all the way back into chapter 2 a little bit also. Okay. So this is our method if you want to eliminate fractions. It's a fantastic method. I recommend using it. But if you don't want to use that method, that's fine. You can work with everything as though you were just working with fractions. Add or subtract fractions together the exact same way as we did in the past. We have these 2 options for eliminating fractions. And our final step, if we have a fraction attached to a variable. And again, I'm fine with whichever one that you would like to use. I think multiplying by the reciprocal saves you a couple lines of work by comparison. But again, it's your choice as to which one you would like to use. They will both work. Okay? So I think the biggest thing that throws people off with this section is my last thought for what we're going through today for our lecture notes. A big thing that throws people off in section 4.8 with all these fractions and everything going on is people saying, and it is very understandable, I have so many fractions going on, I know I have multiple choices and I know what those are, but I don't know which one is better or which one I should use in this scenario. It's a completely reasonable question to have, or thought to have, really. But I'm telling you right here, right now, both will work. You just need to pick one, commit to it, and then move forward with it. You might find at the very end, yeah, you know, the other method might have been faster, and maybe. But the worst thing that you can do with all of these options to solve this thing is to say, I don't know which one I should pick, and then you freeze up and don't do anything. You have the 2 methods, just choose one and move forward with it. Okay? So that is everything that we have for 4.8 today. I'm going to go ahead and end the recording there, and then I'll take any questions that you guys have.